I am James Malone, and I'm joined here today by Karthik, who's going to come on stage in a few minutes and run through a demo. And today we're going to talk about Cloud Spark and Hadoop, specifically on Google Cloud Dataproc. The session today is going to mix a few things. First, for anyone who hasn't actually used Dataproc or doesn't know what Dataproc is or what we do or why we've done it, I'm just going to set a baseline and talk a little bit about Dataproc, some of the common design patterns, some of the common advice. Specifically, I'm going to try and focus on things we've told people in the past to try and help them go from on-premise or in other clouds to Cloud Dataproc. I'm then going to turn it over to Karthik, who's going to talk through some of our new exciting features. Some of them we haven't publicly announced yet, so you will actually be the first group to know about some of these. Those features are really designed to help make adopting Cloud Dataproc faster and easier. So first, I want to start off with looking at just traditional Spark and Hadoop clusters. A lot of Spark and Hadoop clusters, when people run them, are monolithic. So they get a set of compute, they get some implementation of Spark and Hadoop, they slap it on the hardware they've requested, and that hardware could be bare metal, it could be VMs, it could be kind of whatever. Often we see that those clusters are off by themselves. There may be point integrations. People run into the challenges of trying to balance that cluster. So a configuration, it's sort of a butterfly flaps its wings over here. It causes trouble over here. A small configuration change, you then have to think about how it might impact the whole cluster. People have tenancy problems, either in terms of their security model, their resource utilization, their configuration. It really ends up being a bit of a frustrating mess that people are just babysitting their cluster and paying less time to actually getting value out of Spark and Hadoop. And to be honest, we see it turns a lot of people into really frustrated users of Spark and Hadoop, which is unfortunate because they end up kind of hating the tools because there's so much just pain involved in managing their clusters, which sucks. Like it shouldn't be that way. You should actually like the open source you're using, not be beholden to it. So this is what I often refer to as the devalue chain of big data when people use open source. You get this hardware, you then have to configure it. Cloud has done a good job of removing some of this pain. So instead of needing to rack servers and configuring them, you might just get a VM, and that's great. But even then, you have some open source implementation or a proprietary implementation of Spark and Hadoop. You then need to tune it, configure it. It is a really, really frustrating experience for a lot of people. We see a lot of time spent in people trying to manage their clusters. A lot of people that we run into think they also need to do this because it becomes a part of how they've operated for so long. So they've gotten used to administrating their cluster, and there's a core set of tasks that they think they have to do. And when we try and peel that away, they don't. And a lot of time that they could have dedicated on writing Spark to go look at data or backfilling old data to find new insights or anything that's higher value than sitting on their cluster, they're not doing because they're spending their time on their cluster. Leads to a whole bunch of pain. So scaling, even in a cloud environment, can be really tricky and really painful. Utilization. Unless you're running ephemeral Spark and Hadoop, utilization is a bit of a moving target. So you're trying to plan out both how much you think you need right now, which can actually just be tricky, and how much you think you might need in the future. So unless you're using ephemeral Spark and Hadoop, you're trying to match how much you're spending with how much you're using. And again, you're performing more accounting at that point and sort of less engineering or less technology. We really think that the cloud should make just focusing on your data much easier. So instead of focusing on the cluster itself, we want you to focus on the technologies. So you don't want to focus on your Spark and Hadoop cluster. You want to focus on Spark and Hadoop. And that's really why we went out and designed and continue to invest in Cloud Dataproc. So if you like using Apache Spark and you think there's awesome new features in something like Spark 2.3, which there absolutely are, we want you to focus on those awesome new features and the value they might bring to your data, not how you have to think about when you can upgrade to Spark 2.3 on your cluster or how you're going to try and fit it into your existing production workflows. So with Cloud Dataproc, and if anybody has seen past presentations, this is a familiar phrase, and it's a familiar phrase because it's sort of our mission statement, and it continues to underpin our thinking in new features that we develop for Cloud Dataproc. We want the Spark and Hadoop ecosystem, and when I say that, that's the whole bucket of components. There's a lot that lives in there. There's HBase and Tez and Impala. And so I often abbreviate it saying Spark and Hadoop ecosystem, but it's really that whole big thing. And some of it is, well, most of it's in the Apache Software Foundation, but a lot of it's also related. It could be things like Presto. So just as a note, when I say that, I sort of mean I'm speaking to the whole ecosystem. That's where Dataproc plays. Fast, easy, and cost effective. So realistically, we do want you to spend less to do more. Salespeople love me for saying this, but when you're using Spark and Hadoop, save your money for high-value stuff. If you have a Spark job, pay us for the compute resources and for the management to go run that Spark job, and then don't use the resources when you don't have to. Use them for something else. Hire more people to look at your data or throw a party, whatever. We don't really care. We just don't want you to waste your time, your energy, and your sanity. When you look at sort of from fully DIY to Cloud Dataproc, there's a few differences. Obviously, when we interact with a lot of customers at the beginning of their journey, they're running their own managed clusters, sometimes in a cloud, sometimes on-premise, and they're taking on the full burden. So they're managing their hardware, they're managing the software, they're managing the configuration. They may bring in a vendor to help with the Hadoop stack, which is the middle column. So the vendor can help pre-tune some of the components. They will create builds for them. They'll often provide support, but there's still a lot that the customer is responsible for managing. With Cloud Dataproc, we want you to focus on your code and your data and not other things. That's not to say we want to abstract away your ability to do things like custom tune Spark or inject new libraries or do really advanced things. Dataproc as a Google Cloud service stands out because it's really knobby. You'll find a lot of Google Cloud services are not knobby. On purpose, Dataproc is a very knobby service. Our philosophy is we want it to be knobby. We want to preset those knobs to the best of our ability, and you'll see some of the features that we're working on today to add new knobs and preset those for you. But we want you to be able to override, to configure, to tweak, but not have to think about it if you don't want to, because most of the time you just don't have to think about it. Under the hood, Dataproc has a few different layers. I'm going to be describing this left to right, just so people can follow along. Everything that happens with Dataproc generally happens through the Dataproc API. And that's not to say that all interactions have to happen through the Cloud Dataproc API. It's just how many happen to work. So all of our client tooling, whether it's the Cloud Console or the command line SDK, they're all talking to Dataproc API. There's endpoints for clusters, jobs, operations, and now very recently workflows, where you can specify a workflow that will allow you to create a cluster, execute a graph of jobs, and delete the cluster in one operation. That API will talk to Dataproc clusters themselves, which are built on top of Compute Engine. Dataproc clusters have n number of master nodes, depending on whether you're running just standard availability, which is 1, or high availability, which is 3. Those nodes then run Debbie and Jesse image with our open source stack, which we use Apache BigTop to build on top of it. You can install additional components if you want to. Likewise, since Dataproc is running on Compute Engine, you can do things like SSH into the VMs if you so choose. We also inherit all of the power and functionalities of Compute Engine, so networks, GPUs, the ability to create clusters without public IPs attached to them. All of that is inherently part of Dataproc, because we're built on Compute Engine. You also see HDFS. And HDFS is a bit of an interesting odd duck here, because when you create a Dataproc cluster, we do provision HDFS. The goal is that you'd only use that HDFS for temporary operations, so splitting, spilling, shuffling, but you wouldn't store data on HDFS persistently. And the reason being is we have a cloud storage connector that's Hadoop compatible file system compliant, which allows you to use cloud storage as an HDFS drop-in replacement without having to run your cluster 24/7 just to run HDFS. So when a lot of people move to Cloud Dataproc, the very first sort of big savings for them is just not running a cluster all the time to maintain their data. Over the years, there's been a set of common pieces of advice we've given customers to try and help them get onto Cloud Dataproc as sort of painlessly and effortlessly as possible. First, separate storage and compute. And this goes to my quip about HDFS. So to the extent that you can separate your data at rest from your computation, you'll save, obviously, effort. You'll save money because you won't have to maintain the compute needed just to store data. It also allows you to do an incremental move over time. So if you separate out your storage and compute, you can do something like move just a portion of your data to cloud. You can experiment on it. You can move maybe just a few jobs to Cloud Dataproc, see how it works, iterate, rinse, and repeat. It means you don't have to do a wholesale lift and shift of your cluster all at once, because that's really difficult to do. It means that people are trying to move a lot of moving parts. It's much easier to do it incrementally. When you also separate out storage and compute, it means that if you put some storage mechanism like cloud storage, you can use it with other Google Cloud products like BigQuery. You don't have to think about it. Use ephemeral and long-lived clusters. So Cloud Dataproc is best used ephemerally because you can create clusters in under 90 seconds. You can delete them at any point. We bill by the second. So from a performance and economic standpoint, there's a lot of reasons to use ephemeral clusters. May not always be able to because you have Spark streaming, or honestly, if you actually just want to run a persistent cluster, some people prefer to do that because the predictability of their jobs is unknown. They have internal SLAs where seconds matter, whatever the reason is. Using a mix of ephemeral and persistent clusters works out for a lot of people. Right-sizing clusters. So open source packages are great because they allow you to do a whole lot of really awesome things. They're really hard to use all on one cluster because the way that you need to configure the environment in terms of the software, in terms of the compute resources, maybe in terms of the location where your data is just located, can all vary. So depending on the type of thing that you want to do, maybe the SLA that you have, maybe you don't care if your Java MapReduce jobs take forever. Maybe your biggest reason for moving them cloud is save money. It's fine. You can create a small cluster, have it finish whenever you're ready. You can size it just to fit your preferences. If you have Spark and you want it to run as fast as possible, you can right-size that cluster for that use case. Create and delete clusters often. The too long didn't read version is if you don't have a reason to keep your cluster, just delete it. Like, please don't give us money to just run stuff and just let it sit idle. That's a bad use of your money. The jobs API. So when we meet a lot of customers and they're moving to Cloud Dataproc, they're using things like their own custom interfaces or web-based interfaces to try and submit, I don't know, HiveQL or submit and manage Spark jobs. Cloud Dataproc has a jobs API that sits on top of clusters. It allows you to submit and monitor jobs for some of the more common job types. We recommend that people do it because you can do things like stream output in real time. The job metadata will outlive the cluster, so if you delete the cluster, all of the information about your job will still be there. It also just makes your life easier. You don't have to think about web UIs to try and submit jobs. You don't have to think about trying to create user accounts for people to be able to go create accounts and submit jobs on clusters. It just functionally makes your life a lot easier. The common advice has worked out really well, but there's a set of new features which are either in Cloud Dataproc today or are launching in the next few weeks that will hopefully make moving to Cloud Dataproc just faster and easier and more cost-effective. And Karthik's going to run through some of those new features with you. He's going to run through some of them, but not necessarily all of them. So if you are an avid release note fan, Cloud Dataproc does do weekly releases. As a teaser, there are things that are not covered here that are also coming out in the next few weeks, just to set that up.
Alrighty. So I'm Karthik. I'm a software engineer on the Cloud Dataproc team. I'm going to introduce you to 3 new features. So the first one is custom images. So our base Dataproc images come with 4 components: Hadoop, Spark, Hive, and Pig. But oftentimes you want to run more than that. Sometimes you can bring your Java dependencies with your job, but oftentimes you need to bring a lot more. So if you're installing servers or you're compiling like Python dependencies from source, that can take a lot longer. So once your initialization actions take more than just a few minutes, now if you create a large cluster, and your init actions, I've even heard a customer take an hour. Now you're spending all that time just configuring the cluster, not actually processing the data. So the custom image, you can build an image and then give that to Dataproc to use for your clusters. And that really helps you use ephemeral clusters. So I'm going to just go through a quick demo here of creating a custom image. So first, actually, I have this bash script called install kitchen sink. So I'm installing Jupyter, RStudio, Apache Zeppelin, TensorFlow, and the HBase client for Bigtable. So just a bunch of random things that take several minutes to do as an init action normally. So since I don't want to waste your time, this would take a few minutes, but I already have a custom image pre-built. So I'm going to create a cluster based on that. All right. All right. 0.3. OK, so as you can see, the default here is the base Dataproc image. And I'm going to go ahead and change that to a custom image here. Hadoop demo project. And this is the one I already pre-built. So I'm going to select that. Go ahead and create it. All right, so 452. Anyone want to guess how long this will take to create? 60 seconds, a little bit longer than 60 seconds. I would guess closer to 90 seconds. But as this is creating here, you can see that there's a custom image. I can go ahead and click on it. And this image is in the GCE images list. And so this is managed by me. And so I can go ahead and delete it if I don't want it anymore. All right, we don't care about that one. I'm just going to quickly show you here. Just kidding. The cluster is not created yet, but I just was going to show you. Yes, now it is created. Oh, hello. Just check here. Kitchen sink demo 2. There we go. All right, so you can see that this cluster already has Jupyter pre-installed because I created a cluster with this custom image. You know, I have this like TensorFlow hello world here that we could run. So that's custom images. All right, so the second feature I want to talk about here is Dataproc workflows. So with workflows, you can specify a cluster that you want jobs to run on and also the jobs that you want to run. So this really gets to kind of using ephemeral clusters. Previously, you would need to manage 3 different operations. You need to create a cluster, run jobs, and then delete a cluster. But with workflows, you can do all of that in one step. So really helping with the automation there. Just kind of one deep dive here. With the workflow cluster, you can either specify a cluster that the workflow will create just for those jobs and tear down at the end, or you can give it a selector. So if you want to manage your own pool of clusters, like let's say you have several clusters with the same label, then you can ask the workflow API to run jobs on the least loaded cluster with that label. So I'll quickly show you here. So this is a workflow template. I like to use YAML files to specify my workflows. So this is a pretty common Hadoop workload. It's called TerraSort. So I have TerraGen to generate a terabyte of data. TerraSort sorts the data, and then TerraValidate validates that it was sorted correctly. And you can see that I'm using paths on Google Cloud Storage here for the data. And then finally, at the bottom of this file, in this case, I have a managed cluster, and the only configuration I was setting was the number of workers. So 2 is probably not enough workers for this cluster, so I'm just going to go ahead and set it to 100. as just as a guess. So I can go ahead and create this. So instantiate from file. Cool. So this workflow is going to create a cluster, run the 3 jobs one by one, and then finally delete the cluster at the end. So I don't need to manage those steps independently. So as you can see here, it's creating a cluster. All right. And again, canceling is also simple. So if I don't want to actually wait for this to finish, I can go ahead and cancel it. So pretty neat. Helped me get rid of a lot of bash scripts, actually. All right, so this is the last feature I wanted to talk about, auto-scaling. So as James was talking about before, one of the real benefits of cloud infrastructure is that you can provision and delete nodes, delete VMs on demand. But before, with Dataproc, you would still have to notice that your cluster was either underutilized, or maybe you had a lot of work queuing up, and so you'd have to manually resize the cluster. But now, we have auto-scaling. So as James was mentioning, we do try to be a more knobby feature than a lot of the rest of Google Cloud. So with auto-scaling, you have complete control. A lot of these do have defaults, but you can specify things like the min and max workers for primary, so standard and preemptible workers. You can specify the cooldown period, so how often the autoscaler decides to scale. Things like graceful decommissioning and several other properties. Yes? It can. So the question was, can it scale down? And the answer is yes. Say that again? Yes. Yes. So I'll explain. So a quick little deep dive here. The way this works is it's purely based on Hadoop Yarn. So if you're unfamiliar, Yarn is the scheduler of Hadoop. So if I have 100 nodes and each has 10 gigabytes, then I have 1,000 gigabytes of virtual Yarn memory in my cluster. So if I have available memory from Yarn's perspective, that means that I'm actually over-provisioned. I have too many nodes and I can scale down. And similarly, if there's a lot of work queued up in Yarn that doesn't have space to be allocated, I have pending memory, and that means I need to scale up the cluster. So the auto-scaling policy is purely based on that. And so when we're talking about Spark, Spark as a job, as executors exit, then you'll end up having available memory, and so we'll remove VMs to match that workload. So a quick demo here. I actually love using workflow templates, so I just modified my previous workflow template and added some auto-scaling properties. So here I have a max of 100 standard workers and 100 preemptible workers, so a total of a maximum of 200 nodes. And I asked it to scale every 10 minutes. And just for fun, I decided to add in the custom image we built earlier. So similarly here, it would be instantiate from file. And of course, this would take several minutes to run, actually more like an hour to run. So we're not going to wait here for that. I have run this before, and I'll show you the dashboard. So this is Stackdriver. All right, so there are 3 jobs. You can kind of see them on the left here. The green right here is pending memory, so this is work queued up. And you can really think of this as the amount of work remaining in the job. So this first stage here is Terragen. So you can see that this is definitely smaller than Terra's sort. So what happens here is that initially, it's very slow to progress. You can see that it's pretty flat on the left. But then, if you look over here, the autoscaler scales up, which makes the work go down a lot faster. Similarly, TerraSort is a lot bigger job, so there's a lot more pending memory, and again, the autoscaler scales up, and so again, the slope is a lot steeper as the work finishes faster. And then finally, TerraValidate, the cluster is about the right size, and so it's mostly constant. And then finally, it's deleted. So pretty neat. Sorry? Shouldn't the nodes down? At the very end, I was wondering that too. You can see that it kind of goes up here as well. Pending memory is still non-zero, so there is still actually work pending. At the very end, the cluster just gets deleted before the next cooldown period, and so that's why it just drops off there. I have one more kind of neat demo. So this one was not done from a workflow template, which is actually why there's like a few hours where the cluster is just sitting idle. I actually forgot to delete it. So use workflow templates. OK, so this workload, I was adding more and more load up to kind of this point here, and then reduce the load throughout. So the chart, sorry about that. So this is actually a bit misleading. I am still increasing the workload as it falls down. It's just that the autoscaler scaled up as it detected more and more work. So around here, the cluster is about the right size. And then when I add a ton more work, again, the cluster scales up. And then finally, as the work comes down, it scales back down. So that's autoscaling. Yes? So the question was, does autoscaling only work with workflows? The answer is no. It's based on Dataproc cluster properties. So in gcloud, if you ever use -- properties, often for like Spark properties, it's the same thing. And we will have more time for Q&A at the end, so don't worry too much. So a quick recap. I'll go back to presenting here. So we created a custom image. We wrote workflow templates. We enabled autoscaling, and we saw the cluster autoscale. So again, this really gets to kind of us becoming a more and more managed service and really helping you automate your workflows. So with that, I'll hand it back to James.
So a few of those features are there right now. Autoscaling is coming in the next 2 weeks. The feature that I alluded to earlier is also coming in a few weeks is selectable components, where you can pick and choose what you want installed on your cluster, which should make it easier to customize the cluster to your liking. If you are curious and want to get started more with Cloud Dataproc, there's a few things that you can check out. There's a set of migration guides, which we're expanding over time. Migration guides are written from the perspective of you already have a monolithic or several monolithic Spark and Hadoop clusters. You want to move them to Google Cloud. There's information in the migration guides right now about moving your jobs and moving your data. We're expanding that soon with a guide on how to think about a security model in a cloud environment versus a traditional on-premise environment. The Cloud Dataproc docs always have our newest features. So when we release new features, we release documentation. If you are really curious to stay up to date with Dataproc features, the best thing to do is actually just follow the RSS feed for our release notes. We do a weekly release. Behind the scenes, if you ever look at the Cloud Dataproc images, you'll see that they're incremented every week. And the reason is we're continually building new images every week. So it's a really good way to stay up to date. We also have a Stack Overflow tag. The team actually looks at new questions that come to the Stack Overflow tag. If you have a question you think others might be interested in that question, or you think there might already be an answer, I strongly encourage you to use that tag, both just as a basis to see if somebody already has asked a question, or just to share your question so others might be able to find that information as well.